I have a game I'd like to play with you, and with this game, I'd like to explore an amalgamation of two ideas. One of these is physicist John Wheeler's idea of it from bit. Essentially, it proposes that everything in the universe derives its existence from answers to yes-no questions. I presume he was led to this idea by quantum mechanical experiments that suggest a property of the universe does not seem to have a definite value, for example, position, until we ask it, aka run an experiment. We will combine this idea of it from bit with cognitive scientist Donald Hoffman's interface theory of perception, which claims that our experience of reality is just an interface for an underlying structure that is quite different to what we perceive. So firstly, I will propose a possible primitive toy fundamental reality, and then we will use only answers to yes-no questions to construct our interface for that reality. This primitive reality must have as few assumptions as possible. It must not contain time, space, causality, or computation. I believe that time, space, causality, and computation are aspects of our interface, not fundamental reality. Why? Because if you put them in at the fundamental level, you're left with questions of infinite regress, such as what happened before the Big Bang, what implements the computations, what stitched space together with this particular topology. So here is our toy possible primitive underlying reality. This is Hilbert Space. More precisely, it is a Hilbert Space for a 3-bit binary string. That just means that it is a collection of every possible state we can make with 3 bits. I could have chosen a larger Hilbert Space, but 3 bits is enough for our demonstration. It is important to state that this is a static structure. It does not change. There is no time, there is no space, there is no causality, there is no computation. Just the collection of all possible binary string states all at once. And here is our sparse interface. It is represented by buttons which have no labels. It also has a dial that indicates yes or no. This is an interface for our binary Hilbert space. Much like how the desktop of our computer allows us to navigate the confusing ones and zeros that lie within it. This is our interface to reality. It is how we will experience reality. There are no labels on these buttons, and that is because we cannot be offered our interface pre-made by some entity that is external to reality. We must create our interface based on our experience with reality. The third thing I need to introduce you to is you, a conscious observer. Now, as a conscious observer, you will probably agree that consciousness is experienced in a stream. We don't experience all states of our life at once. To do so is not a coherent, experienceable way of interpreting the data. We experience them in a single thread. So, back to our Hilbert space. If we are to view these states individually in some order, there are 8 different states, therefore 8 factorial different orderings that we could have. If we click this shuffle button, we get a new possible order. Think of the stream of states down the page as the stream of consciousness throughout your life. So now we have introduced a notion of time, simply an ordered thread through the possible states. Each state in our order represents 1 tick of time. We have also introduced what consciousness is. Consciousness is a pathway through Hilbert space. It is important to stress that it is not an outside observer looking at the pathway. That would require something external to what we have already defined as all existence, which would be a paradox. Consciousness simply is the pathway. Now, most of the possible pathways will be incoherent white noise, but some of them will have the necessary correlations to be compatible with a stream of coherent conscious perception. Now, since this toy Hilbert space is so small, for this demo we're going to be allowed to pass through our stream of consciousness multiple times, as one pass will not be enough to figure out some useful order for our interface. So starting with our blank interface, let's try to build our interface with nothing but yes-no questions. We will only ask one question at each time step and then move on to the next state in our stream of consciousness. You will notice that when I click on a button, this yellow needle moves to point either up or down. You can think of this as an arbitrary basis. We can define up as yes and down as no. Note that we have no idea what questions these buttons are actually asking. Now there is another needle here. This needle, the red needle, indicates the running average for the button being clicked. Its direction is a vector representation of the probability of getting yes or no. You can see highlighted here the current state that we are on. This is the state we are questioning. You will see that if we keep pressing this button, we move to a new state in Hilbert space with each click, and our red probability needle starts to converge upon a particular direction. So even though our yes or no answers seem to come non-deterministically, we soon see that on average for this button, we get yes 50% of the time and no 50% of the time. Our probability needle has therefore converged to halfway between yes and no. So let's relocate our button to the position that the probability arrow has converged to. Let's try another button. This one converges to a 25% chance of yes. Our needle is pointing to the direction that corresponds with this probability. So let's move this button to that position. Now I'm going to speed up the video as I complete this with each button. You can see that we were able to spread our buttons out all around the dial. Each button has a certain probability of getting yes. We have now essentially given our buttons direction labels. Left, right, 60 degrees, etc. And direction is synonymous with the probability of getting the answer yes. As observers of this interface, this is the only label we see. Without knowing what question these buttons were actually asking, we were still able to organize them and give them a label based on the probability of their answers. So, what questions were they asking? Well, they can only be asking questions about the current state of Hilbert space that we are on. And since Hilbert space is made of binary strings, our questions have to be about binary strings. So let's look at the button that we have labeled left. This is the button that gave us yes 50% of the time. So let's uncover this button to see what it was actually asking. In the game, you must press Q on the keyboard as you click the button in order to display its question. This button is asking the question, does this state start with a 1? If we look at our small Hilbert space, we can see that yes, 4 out of the 8 states do start with a 1. That's yes 50% of the time. So when we are asking the question, are you in the direction left, we are actually asking, do you start with a 1? Let's uncover this button. Do you start with 1, 1? You will see that 2 out of 8, that's 25% of our states start with 1, 1. So we can expect a yes answer to this question 25% of the time. If you would like to see the questions related to the other buttons, follow the link in the description so that you can play this app for yourself. This demonstration is intended to show how we can create a notion of direction from a reality that fundamentally has no space. It is also depicting something called the Stern-Gerlach experiment. In the Stern-Gerlach experiment, we fire an electron through a magnetic field. We find that the electron gets deflected in one of 2 directions parallel to our magnetic field lines. These can be thought of as our yes-no answers. If we tilt our magnetic field lines relative to the prepared spin direction of the electron, we find that our probabilities of getting yes or no are related to the angle of the magnetic field. A field at 90 degrees gives 50-50 yes and no answers. A 120 degree field gives a 25-75 distribution of answers. In quantum mechanics, we have long been puzzled as to why particular probabilities happen in certain directions and locations of space. But I propose we simply have it the wrong way around. Probabilities don't happen in space. Space happens in probabilities. Probabilities are how we construct space, how we construct our notion of direction and position, how we construct space in our interface. We can use a similar method to show how a notion of position can be created from just yes-no questions. We will do this with another game, in the context of the double slit experiment. You can see here our buttons, each asking a unique question. There are a couple of differences in this game. We're now using an 8-bit Hilbert space, which gives 256 different states, which are now running down and off the page. And rather than asking one question at each time step, we're going to ask all questions. Think of it as if each point in space is asking, "Are you here?" Now the point of this game is to find a useful ordering for our buttons, an ordering that we will call space in our interface. Now I've already played this game and I've gone ahead and ordered the buttons for you. I've also labeled them with the question they are asking. So let's go ahead and click Fire. So all of our buttons have just asked their question of the current state, and only this one got the answer yes, aka we have observed a photon here. Now this button is asking the question, do the first half of bits add to 1? And do the second half add to 3? If we look at the state we are on, we can see that yes, that is the case. This button currently has a 100% chance of answering yes, because we have only asked one question. Let's fire another photon, aka move to the next state in our stream of consciousness. And now another. We now have 3 buttons, each with their probability of answering yes. Now, rather than clicking through all 256 states manually, I'm going to fire a stream and sit back and watch what happens. You can see that what emerges is our familiar diffraction pattern. Now these buttons have no defined order. It was me that put them in this order, but only after realizing that their probabilities fitted perfectly into a diffraction pattern. This is a useful way to order them in our interface, as it allows us to treat probabilities as if they were waves. We have constructed a useful space interface from the probabilities. Once again, probabilities do not happen in space, space happens in probabilities. So what about causality, aka computation? How does this emerge in our interface? Well, each of the questions on the buttons we have been using can be formulated as a particular arrangement of logic gates in the circuit of a quantum computer. Now, what a quantum computer appears to do is manipulate the probabilities of certain states in Hilbert space being in our stream of consciousness. Different quantum circuits create different pathways through Hilbert space. For example, this quantum circuit creates entanglement. Entanglement basically says that if bit A and bit B are sent through as 0, 0, they must always be measured to have the same value once they have passed through our quantum computer. We will see 1, 1 or 0, 0 with 50% probability of each. We will have eliminated the chance of seeing 1, 0 or 0, 1. Well, once again, I propose that we have this the wrong way around. Our quantum computer does not control our stream of measurement. Our stream of measurement implies our quantum computer. Out of all the different possible states through Hilbert space, there will be some that have a long stream of 1, 1s and 0, 0s, and no 0, 1s or 1, 0s. It is at this point in the stream that we think we have a functioning quantum computer to produce our entanglement. Now each pathway through Hilbert space will be identical to a possible stream of states produced by a particular evolution of quantum circuits. But there is no quantum circuit. The circuit does not compute the next state that we observe. The next state we observe implies the existence of an evolving quantum circuit. And on a large scale, those quantum circuits look to us like experiences of atoms, rocks, trees, and neurons. So an interesting app to make next would be one that streams through our random pathway through Hilbert space and generates our interface in the form of the implied evolving quantum circuit. The question becomes, what evolving quantum circuits are adequate for coherent conscious experience? And what are the pathways through Hilbert space that imply those circuits? Now, I will stress that I am not a physicist. My formal training is in mechanical engineering, and I've probably made many mistakes in this video. but I'm really putting these ideas out in the hopes that people with more knowledge than I might point out the errors or add insight to this way of explaining reality. There is plenty I've not addressed in this video, such as where does our third dimension come from, where are the complex numbers, what produced Hilbert Space. So click subscribe to get notified about future videos, hopefully filling in some of the blank spots in this theory. If you have some answers, questions, or issues with my methodology to point out, please get in touch or write them in the comments. If you have words of kindness, then don't hesitate to write them too, as they make me happy. Thank you.